Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So for this question, I think of the ratio in terms of piles. So food is getting 37 piles of money and drink is getting 4 piles of money. So we've got to first of all work out how many piles of money we have. So we're going to do 37 plus 4 and that will give us 41. So we've got 41 piles of money. Now each pile is equal, so to work out how much one pile or one part is worth, and in maths we call them parts, but they're just like piles of money. We're going to do 13,161, the total amount of money, and we're going to divide it by how many piles there are, 41. When we do that, we get 321. So each pile is worth 321 pounds. Now, if we look at how many piles drink had, well, they had 4 piles. So we're going to just work out 4 lots of the 321. Which is going to be 1,284. So they spent £1,284 on drink. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other 2 in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it would be A squared plus B squared equals C squared, but this time A is 39. B we are given as 47.148, we've just worked that out. And we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X squared. And we just get our lines in because we need to square root both sides. And we get 61.188 blah 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 is equal to x. It says it wants its 2 decimal places, so that will be 61.19. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.692. 0.69. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79, and that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is minus 2. And then the bottom will be 6, take away, minus 4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop, and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away, and we want to minimize this distance here because we don't want them to have made that much distance towards their house, because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10. And a trick you can do to find out what the upper bound is going to be is just half the accuracy. So 10 meters to the nearest 10, half of that would be 5, and then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve the accuracy. 10 would be 5. And this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. The first thing to notice is that 125 is 5 cubed, so instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO. Same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. When asked to simplify an algebraic fraction, you will almost always need to factorise either the numerator, the denominator, or both. On this question, we need to factorise both. So I'm going to start off by factorising the top. Now you'll notice that this is a difference of 2 squared, so this is nice and easy to factorise because it will be x plus 2 and x minus 2. And we've got loads of videos on how to identify and deal with difference of 2 squareds if you don't know how to do that. Similarly, the bottom is just a simple quadratic, so we're just going to factorise that. Again, we've got videos on how to factorise quadratics, so have a look at those if you need to. Then we're going to look at top and bottom and see if there's a bracket that's the same, which there is, this x minus 2. So we're going to divide top and bottom by x minus 2, and that will effectively get rid of the x minus 2 at the top and the x minus 2 at the bottom. It won't get rid of it, it will just turn it to 1, and then it will be x plus 2 times 1 and 2x minus 3 times 1, which will just be x plus 2 as the numerator and 2x minus 3 as the denominator. To answer this question, we're going to do something a bit weird on the calculator, and this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this, the cube root and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309 equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.